Hello YouTube, welcome back to the channel. So in today's tutorial we're going to continue with our introduction to statistical analysis with Python. So if you're a person who is willing to learn data analysis in Python, learn all the fundamental statistical concepts, then this series is for you. So we have been building this, going over this series. Now this is practical number 7. In practical number 7 we're going to look at the measures of dispersion. Okay, so this is the question that we have. Like as we always do, we start the question and then we learn how to solve that question, and then we apply our knowledge to solving the question, and then finally we have an assignment to practice our knowledge on, right? Because there is no point of learning something if you don't know where to apply it or how to use it to solve a given problem. And there's no point of learning just random stuff. You learn stuff that actually have real uses. Like that's why we start with the question, right? So let's jump on to the question. The question says calculate the variance, the range, the standard deviation, the interquartile range, the skew, and the Kartosis from the credit amount column inside of the credit data set. State any observation you noticed. So this is what we're going to be going over. Okay, so we have the measures of central tendency. There are a couple of them. There we have the variance, we have the range, we have the standard deviation, we have the interquartile range, which is the IQR, and then we also have the Kartosis. So let's begin by defining what each of those are. So variance is the measure of dispersion, checks the spread of the data about the mean, right? That's basically, so variance just checks how to spread the data is from around the mean. Okay, the average square deviation from the mean, that it can also be called that. So it's the average square deviation from the mean. And what's range? Range is the difference between the highest possible value within a given column and the lowest minimum or the lowest possible value within a given data set. That is basically what the range is. And let's look at now what standard deviation is. So the square root of variance, right, is a measure. It measures the spread of the data about the mean. So the square root of variance is what we have called standard deviation. So if you want to get it, because if you have standard deviation, maybe you are calculating something dealing with units that have data that has unit or in kilograms, right? So the variance will be squared, right? So the square root of it, you get kilograms instead of kilograms squared, for example. So that's basically what variance is and what standard deviation. So standard deviation is just the square root of variance. That's basically it. So let's look at what interquartile range is. So we have something called quartile. So the data can be divided into 4 main quartiles. We have the first quartile, the second quartile, the third quartile, and the fourth quartile. So the difference between the third quartile and the second quartile is what we call the interquartile range. So we take the third quartile minus the first quartile. What we get is called the interquartile range. That's basically it. So let's not waste much time about this. If you don't understand, you can just pause the video and listen to it over again and read the things here. Let's move on to the next slide. So let's look at measures of dispersion, right? So we're going to look at now what skewness is. So skewness is a measure of symmetry or lack of symmetry inside of the data. Symmetry means that the both right and the left side are equal, right? That's what symmetry is. So whenever you want to check if the right side of the data, right, if you draw like a normal distribution plot, if you want to check if the right side is the same as the left side, then you can use skewness to check this. So a positive value positive skew value indicates a positive skew, a negative value indicates a negative skew. So what does all this skew means? We'll look at it just more look using a graph. So data is skewed when the mean equals to the mode equals to the median. Okay, so this you might be confused, but to look at it just a bit, I have a graph that explains this furthermore. So data only becomes skewed when the equilibrium is broken, when the mean is not equals to the mode or is not equals to the median. When this equilibrium right here it becomes broken, then the data becomes skewed. Okay, so when the equilibrium is not broken, the data is considered to be not skewed. Okay, so we have it right here. So this is the we have frequency, and then we have the plots here. So we have the mean, the median, the mode, right? The mode is the number with the highest frequency, so it will be at the peak of our plot. So if the mean is not equals to the median is not equals to the mode, then the data is considered to be skewed. In this case, the data is negatively skewed, since these are called the tails of the data. Right here are called the tails. So you can see that the tail is skewed far to the left side, so it's called negatively skewed data. Okay, and if you look at this one, you have the median, the mean, the median, and then the mode, and the tail is pulled further to the right side. So this is called a positive skewed data. When the tail is pulled further to the right, is a positive skewed data. Now let's look at when the mean is equals to the mode, it equals to the median, and equals to, mean equals to the median equals to the mode. And if that is so, then the data is normally distributed, and then we'll have all the equilibrium being perfect, right? So when you have the equilibrium being perfect, then the data is normally distributed or not skewed, right? So if the data is not the equilibrium here is broken, then we either have a positive skew in this case, or we have a negative skew in this case. So this is negative skew because this tail right here is pulled further to the right, to the left, and this is positive skew because the tail right here is pulled further to the right. Okay, so that's positive and negative skew data. So that's basically what skewness can tell you about a given data set. Okay, let's look at what Kartosis is. So you might wonder what, okay, it sounds like a bit strange name, a Kartosis. What's Kartosis and what's all of that? So Kartosis is a statistical measure that is used to describe the degree to which scores cluster in the tail of, or the peak of a frequency distribution. So it's just used to show how the degree, how data is clustered in the tail or the peak of the distribution. So if I go back here, you can see these are the tails right here, and this is the peak right here. So it just tells us how clustered, how degree to which the data is clustered either on the peak or on the tail of the data set. So that's basically what Kartosis is. So positive values of Kartosis indicate that a distribution is peaked and possesses thick tails, which is called it's a bit difficult to pronounce, so it's a leptokartic Kartosis distribution, rather, sorry. So leptokartic distribution, when the when it's peaked, possesses a thick tail, right? It's called leptokartic distribution. Okay, sorry for my pronunciation. And then we have also negative values of Kartosis indicates that a distribution is flat and has thin tails, that is called platykartic distribution. Again, sorry for my pronunciation of this, platykartic distribution. Okay, I hope I got it right now. Okay, so let's move on to if the Kartosis is close to 0, then a normal distribution is often assumed, and it's called mesokartic distribution. So mesokartic distribution is when the Kartosis is close to 0. When it is a negative value, it is called platykartic distribution. If it's a positive value, it's called leptokartic distribution. So that's basically it. So now let's look at what we have learned right now. Let's look at how we can be able to solve this question. I'm just going to go back to the question. So I will calculate the variance, the range, the standard deviation, the interquartile range, the skewness, and the Kartosis. So variance. Okay, let's move at this, and then let's go back to I'm going to Google Colab, and this is where my notebook which I'm working on this right now. So we have calculated all this in the future. So if you have not run your notebook in a while, just go and click on run all to run it. I've already done that so that you don't have to waste time. So let's go ahead and calculate the variance. So calculate the variance of the credit amount. So it's the variance of a credit amount, right? It's going to be equals to, you're going to say df, and then you're going to go ahead and say we're going to get the credit amount, and then you're going to find its variance. So it's actually easy to just say var, and then that's it will give us the variance. So you can actually go ahead and print that out. So underscore credit underscore amount. So if you run it, you should get the variance of the credit amount there. So it is the variance of the credit amount, and that's all we need. So you have to say select a given column and just say var, and need to give you the variance of it. Quite easy, right? Yeah. So now let's move on to calculating the range, and the range is the difference between the minimum value and the max and the maximum value inside of a given data frame or column instead of a data set. So what we need to do to calculate the variance, the range is actually find the minimum value. So let's say min underscore val, and min val is going to be df, and then you're going to get access to the credit amount column. Okay, credit amount, and then you're going to simply say min. So this is going to return to us the mean value, and you're going to say max value is going to be df, right? Go access the max value, and this is going to be credit. So let me just use a double squares, so that's what I've been using from the beginning. So we say credit amount, right? Go credit amount, and then we say dot max, and this is going to return to us the max. So we're going to get the mean and the max of these values. So you can just say print, and you can print out the max underscore val and the mean underscore val, and then just run that. We should be able to see those two values. So this is the mean, so this is the max, and this is the mean. So the difference between these two values is what we call the range. So to calculate the range, I'm going to say range is going to be equals to the max value, so max underscore value minus the mean underscore value, right? So this should be positive. So what we should get should be positive value, not negative. Okay, so once we run that, we should get the range. So the range, this is the range right here. So great, that's how simple it is to calculate range. Okay, so now that you have looked at that, let's go and look at now the standard deviation of the credit amount column. So when we say credit underscore amount is going to be credit amount is going to be equals to the following. So we're going to say simply say ahead and say credit amount underscore standard deviation. So STD is also, we probably commonly see people calling it STD, standard deviation. Okay, so STD is different from sexually transmitted diseases. Okay, so it's not sexually transmitted diseases, it's just the standard deviation. Okay, so if you're from a biological background, then it's STD is standard deviation and not sexually transmitted diseases. Okay, so I'm going to do STD, and that should return to us the standard deviation of it. So credit underscore amount underscore STD. Okay, that's all we need to do. So if I run it, and then we should get back the standard deviation of that column right here. Okay, so now that I look at it, let's go ahead and calculate the interquartile range. The next question is the interquartile range. Okay, so to get the interquartile range, what you have to simply say Q1 is going to be equals to the following. So when you say DF, and then you're going to go ahead and grab the credit amount column, credit amount, and then you're going to go ahead and simply say quantile, right? So quantile, quantile, I hope that's a spelling, I haven't got it wrong. So quantile, I actually got it wrong. So quantile, and then you simply have to pass in sorry, this is going to be the first quarter, which is going to be 25%, so 0.25, right? So once we have this, we're just going to go ahead and calculate the third quartile, which is going to say Q3, and Q3 is going to be equals to DF, right? I'm just going to go ahead and simply copy this. It's going to be the same, basically the same thing. So I'm going to copy it and simply paste it here, and now the third quartile is going to be the 75%, so 75%. So once we have that, now we can go ahead and calculate the value. So you can print Q1, so you can say print, and you can print first quartile and third quartile right here, and then run the code. That should return to you the first quartile and the third quartile. So now interquartile range is the difference between those two values. So I'm just going to say when we say interquartile range, it's going to be equals to Q3, right, minus Q1. That's basically it, and then you can print the interquartile range out here. So if I run that, that should return to us the interquartile range. So that's how you can calculate interquartile range in Pandas, using Pandas. Okay, now let's go ahead and see what's next. So we are now going to calculate the skewness of our data. So to calculate the skewness, actually very simple. So I just say credit underscore amount underscore skew, right? Credit amount underscore skew is going to be equals to DF, and then you're going to grab the column that you're interested in, which is going to be the credit amount column. So credit amount column, and then just do dot skew, just like that, dot skew. And then just run that. So I'm going to simply okay, I got it. So it's going to be skew, and then I can go ahead and simply say credit underscore amount underscore skew, and then just run that. That should return to us the skew of our data, which is going to be a positive skew. So if you look what's a positive skew, and a positive skew, we said it's called let me just scroll here, it's called a leptokartic distribution, right? That's a positive skew. Okay, so our data is positively skewed, meaning that the tail of the data is pulled further to the right, right? So if I go and show you right here, so our data is kind of distribution looks something like this because it's a positive skew. Okay, so once I have that, now let's go ahead and actually calculate. Let me see what's next. The next question that we have. So the next question we have is the Kartosis. Okay, so let's calculate the Kartosis, and we're going to say credit underscore amount underscore Kartosis. So cart, right? Let's call it cart, and then it's going to be DF, and then you're going to get the credit amount, and then you're going to simply say dot cards here, and then call that. So it's going to return to us the Kartosis of our data. So and then say amount, and then just do cards here, and then run that. Let's see what we get. So I get 4 this value right here, which is also a positive value for our Kartosis. So actually I made a mistake right here. When I told you previously the data was positive skewed, you can see now the Kartosis, the type of Kartosis that we have is going to be a leptokartic Kartosis, right? So that's basically it. Yeah, so that's basically it, how you can calculate Kartosis and all those values. So once you have now looked at the solution, if you have any question, you can let me know in the comment section below. So that's basically it, how you can answer all of this question using Pandas and do data analysis on our data, right? So now we know our data is positively skewed, we know the interquartile range, we know the standard deviation, we know the range, we know the variance, and all of that. Okay. Okay, so now I'm just going to scroll up here, and then let's go on to our assignment, because you don't really learn anything unless you practice, right? So let's calculate. The assignment is simply calculate the variance, the range, the standard deviation, the interquartile range, the Kartosis from the durations column. Okay, that's the assignment I'm giving to you guys. Okay, so if do the assignment, if you have any question, just let me know in the comment section below. I'll do my best to get back to you. So thanks for watching, and see you in the next one. Keep safe.